floor is open.
Oh, there aren't any? There are, and I kept to 30 minutes. Tom.
Thank you. I was just wondering if you could speak a little about those tiny birds at the end. What's known about how they navigate and how they get to where they need to go?
Okay, the question is about how the birds navigate and how they get to where they need to go. That is one of the, there's a lot of science about this, but that is one of the areas where mystery remains. Are they navigating according to Earth's magnetic field like sea turtles? We're not really sure. They seem to have a genetic map which they inherit, which somehow gets these babies from Southampton Island and other places in the Arctic all the way down to Tierra del Fuego, but we really don't know how they do it. One thing that the researchers have been able to show is that the birds have a phenomenal sense of weather systems. So they can sense weather systems that are moving across entire ocean basins and adjust their flights accordingly. And the way the scientist described it to me, he said, shorebirds always have a sense of where they are relative to where they're going. And then he said, and the same question might be asked of us. And he declined to answer it, and I don't think I will either. Tom. Okay, the question was about my saying the horseshoe crabs were saved in New Jersey. I didn't exactly say that. I said, I showed you the picture of the restored beach, and I said there had been a ban on the bait harvest the bait take in New Jersey. But as I said, the IUCN is putting the horseshoe crab on the red list. It's going to be listed, I believe, as threatened up where I live and in New York, and vulnerable in the Delaware Bay because the population there has been stabilized. So the losses have been stanched, but it hasn't yet recovered. The reason that the population has been stabilized, to answer your question, is actually because the ornithologists pushed really, really hard to get the red knot listed under the Endangered Species Act. And they have been advocating vociferously for years that there be restrictions on the take of horseshoe crabs. And so there are restrictions, but if you look at some of the models that are being used in determining how many horseshoe crabs can be taken, and the birds still have enough eggs, we're not talking about restoring the birds for many, many years or the horseshoe crabs to the late 1970s, early 1980s populations for another, I don't know, 50, 60, 70 years. We don't really have that much time when the demand is skyrocketing. So I would say progress has been made in stabilizing the population, but we need to ban the bait industry, and that will help a great deal.
The other incredible aspect of the story, as you know, is that they carry the influenza viruses with them. They're quite harmless in the bird, and it is part of the overall story of influenza and its genesis and the problems that creates for us.
Yes, well, I'm really glad that Dr. Webster is here. He initiated all of this incredible research, and you can read about it in the book. It was St. Jude's is still there every year, looking at the which viruses are coming in, how they're mutating, and it's a really important service that's being done both in the interest of science and understanding how these viruses are coming to this country, and in the interest of protecting the chicken industry, which is very, very big in Delaware and is only a couple of miles away from where the birds are eating.
Could you tell us something about what progress has been made about understanding what makes the blood of these horseshoe crabs so valuable, and whether it can develop an artificial substitute for it?
Yes, the question is the value of the horseshoe crab blood, which begins coagulating in the presence of endotoxin. And that was discovered quite a long time ago now, actually by accident. And many efforts have been made to find a synthetic. And it's the drug companies, the biomedical companies, there's four biomedical companies basically in the United States who are making the limulus amebicide lysate test. And one of them has been pioneering in the development of the synthetic. The synthetic has not been approved by the FDA. This is a very complicated answer, so I'll just try to say it quickly. Because the synthetic doesn't involve blood, the FDA is saying right now that it's not within their regulatory jurisdiction to approve it. The decision would ultimately rest with the pharmacopoeia. The drug companies have requested, I think reasonably, all of them over the years, that the Japanese, the European, and the American pharmacopoeia all be harmonized so that there's only one set of standards that everybody has to adhere to. One consequence of that is that if a standard is going to change, it's not just the US government that makes the decision. In this case, I think the decision is going to rest with the Japanese. Now, the company that has the synthetic has, the last time I looked, and this may have changed because I don't check it every month, had published one paper showing that the synthetic was comparable to the original. Now, given the fact that when the FDA ended up supporting the change from rabbit testing to using the horseshoe crab blood, there were thousands and thousands and thousands of tests and tons of papers. There was a lot of, it was a hard thing to make that transition because this test is really important. So nobody is going to make the decision based on one paper. So while the statement is out there that the synthetic is comparable, there aren't a lot of papers out there talking about that, and the pharmacopoeia has not made a decision to put that in as an allowable use yet. Something's going to have to happen sooner or later because, as I said, the demand is skyrocketing in the developing world, in Argentina, Brazil, India, and China, and the horseshoe crab populations in Asia are depleted. So it's all in the United States, it's all in Delaware Bay, and then up in Massachusetts, where I live. So this is going to come to a head eventually. I mean, it would be nice if it happened before we ran out, but does that begin to answer your question?
Yes, I gather from the detail of the light path on the map that they have been given radio transmitters from time to time, some of the birds.
You're asking about the tracking.
Yes, the radio, have they had radio transmission?
They have,
I ask it because I'd like to know what the success rate of a bird leaving from the north, maybe to the south, and second, related question, how many seasons do these birds survive?
okay, so the question is, how old are the birds, and what is the success rate moving? So the birds, have radio tags on them. That's what we were looking at in Texas. Those only stay on for about 10 days, so they're not very helpful in answering the question that you raised. They do have geolocators on them. I think about 650 or 700 geolocators have been placed on the red knots. They can't have the kinds of satellite transmitters that are on larger birds because basically the transmitter is too heavy for a bird whose weight fluctuates so dramatically. I think there is a smaller one that's out now, but I'm not sure how successfully it's been tested yet. So they're using geolocators, which are battery operated, and you have to retrieve them off the bird, and then you can look at the flight path. It's based on the rising and the setting of the sun, so they don't work north of the Arctic Circle. So Southampton Island is just south of the Arctic Circle, so that's where the nesting is showing up, but I'm sure that's not where most of the birds are nesting because very few of the transmitters are showing the birds nesting there. They just disappear once they get beyond the Arctic Circle, so there's silence, and then they show up again. So the satellite transmission technology isn't up to where they expect it's going to be, but it's not there yet. In answer to your other questions, these birds, once they reach adulthood, basically have a 90% survival rate on these huge migrations. The risk to them is well, they have a 90% survival rate if they have enough food. Now, what was happening in Delaware Bay when the horseshoe crab population was continuing to plummet was that they figured out what the minimum weight is that a bird needs to be in order to get up to the Arctic and successfully breed. And the percentage of birds that were reaching that minimum weight dropped as low as 30%. Now, it's back up now. I hesitate to give the number because I'm not exactly sure, but it's somewhere between 50 and 70%, so it's back up there now. But the greatest risk to these birds is nesting up there. I mean, even if the mother, if they're healthy enough to lay the eggs, it's really tough up there. I mean, if the snow lasts too long, then the nesting season gets shortened. If it's too warm and the bloom of insects happens before the birds hatch, then the babies don't have enough to eat. I mean, they make these long migrations because it's actually safer for them for other reasons. The number of predators up there is relatively low compared to any place else. There's Jaegers, there's Arctic foxes, and that's it, basically. It's very safe up there. But the year that I was up there, of all the shorebird nests that were up there, I think more than 50% of them failed totally. So it's a very hard environment. So they lose a lot at the beginning, but if they can make that first run out, then this is they have one of the highest survival rates of any shorebird.
I think you started to answer my question, and that was, what is the selective advantage of this incredible journey that these birds take?
Yeah, the selective advantage is the lower levels lower risk of predation. I forget what it is for every X number of degrees of latitude. It drops by a certain percentage. So it's relatively safe up there, and the disease is pretty low. I mean, it's freezing up there, so there's not a lot of disease either. So those are the big reasons.
My name is Sean. As a non-scientist, I want to thank you for a very moving.
Oh, thank you.
Thank you very much.